Hi class, this is chapter 8. We are going to be studying the areas of the figures that we've already learned about so far this year. And we're going to start with section 8.1. So you want to go ahead and start a new tab in your electronic notebook. The title of chapter 8 is Area of Plane Figures. So the area of a plane figure is the measure of the region enclosed by the figure. You measure the area of a figure by counting the number of square units that you can arrange to fill the figure completely. So if we're talking about length, 1 unit, whether it be centimeters, inches, feet, yards, whatever the length is, a square unit would be just making a square out of the length of whatever your unit is. So the area that it takes up is how many square units are in the figure. Okay, so you would just count the number of squares in this rectangle. So you already know probably a lot of area formulas. Okay, so the first two that we're going to learn are going to be fairly easy. You will have a lot of formulas by the end of the chapter. Okay, so the first conjecture that we're going to talk about is the area of a rectangle. So we're on conjecture 74, and the area of a rectangle is given by the formula base times height, or B times H, where A is the area, B is the length of the base, and H is the height of the rectangle. So you just count the length. If we're going to find the area of this rectangle, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and multiply it by the height. 1, 2, 3, 4, 5, 6, 7. So this will be 15 times 7 will give you the area of this first rectangle. You will be allowed to use your calculators, and then we will get 107. So for this one right here, it'll be 15 times 7, which equals 105, and that would be square units. That's how many squares make up this rectangle. So the area is 105 square units. Okay, so that is your first conjecture. Make sure you get it typed into your notebook. You can put the video on pause at any time. Here's an example of where you will want to find the area of a shape. Right now, the only equation that you know is for a rectangle. So I want you to use rectangles to find the area of this shape. So that means you're going to have to create some rectangles. Try that again. So I'm going to make a rectangle right here. If I make sure the diagonal goes straight through, I know that the area that I want to count will just be half. Okay, then I can make another rectangle. Find the area, and because the diagonal goes straight through, then I will find half. The one in the middle is pretty self-explanatory. We're just going to count 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, 2, 3, 4. So that's 8 times 4. So in the middle here, we're going to have an area of 32. And then I could make another rectangle bottom left. And then another rectangle here in the bottom right. So I just need to count the base times the height and then calculate the area. So this one, top left here, is 1, 2, 3 times 2. So the whole thing would be 6. We only want half. Over here we have 1, 2, 3, 4, 5 times 2. So that's 10. We only want half. We've already done the center, which is 32. Again, 2 times 3 here, bottom left. And 1, 2, 3, 4, 5, 6 times 3 for 18, bottom right. Again, we only want half. So if you take all the areas and add them up, we will have an area of 52. Okay, so you can always make rectangles out of any shape to find the area, the total area. Okay, another shape we're going to talk about is the parallelogram, which we've already learned lots of things about a parallelogram. We know it is just a rectangle that is tilted. Okay, both pair of opposite sides are parallel. Just as with a rectangle, any side of a parallelogram can be called a base. But the height of the parallelogram is not necessarily the length of a side of the shape. The altitude is any segment from one side of the parallelogram perpendicular to a line through the opposite side. The length of the altitude is the height. So you will want to make sure you get these definitions into your notebook. The length of the altitude is the height. So if we're looking at this parallelogram, that is the altitude or the height. Okay, so pick one side to be your base. The length from the opposite side of the base down to that base is the altitude. It might be outside the shape, like it is here. Okay, so you're going to have to pay close attention when you have a parallelogram. So our next conjecture is parallelogram area conjecture. The area of a parallelogram is given by the formula base times height, where A is the area, B is the length of the base, and H is the height of the parallelogram. I would make yourself a note. You will have to find the length of the altitude which is the height of the parallelogram. If the dimensions of a figure are measured in inches, feet, or yards, the area is measured in inches squared, feet squared, or yards squared. If the dimensions are measured in centimeters or meters, the area is measured in centimeters squared or meters squared. All right, so an example. This first example, you can cut this into two rectangles. Just add the areas together. Let's look at number 4 because it involves some parallelograms. So if you just want to find the area of the shaded region, what you will want to do is find the area of the whole, which is 13 times 9. Which is 117. And then you want to subtract out the area of the two parallelograms. Well, the height is still 9, and the base is 2. So we want to subtract 9 times 2, and there are 2 of those. So if we take 117 minus 36, we get 81. So the area of the shaded region is 81 centimeters squared or squared. Okay, so this is your first lesson of Chapter 8. Again, you're going to have many formulas, so make sure that you go ahead and start memorizing them. See you in class.